What do we remember about functions? Miriam.
Yes.
What do we remember about functions?
Functions
This is not in your notes from this year. This is like Algebra 1, Algebra 2. Yes, Abby?
You usually start it off with f of x.
Yeah, we usually use f of x.
Or whatever letter of x.
What goes in?
And that actually gives us our y value, right? I plug in x, I get out y. What else do you remember about functions?
Like a vending machine.
It's like a vending machine. You plug something in, you perform the function, you get something out. Oh, we did this in Algebra 2. You did. Well, I don't know who you had for Algebra 2, but if you went to this school, you did this in Algebra 2.
I went here for the end of the year, maybe.
Oh, then you missed it. It's also a topic in Algebra 1.
I ain't never seen that right there.
This is just a machine. So Alexis had said a vending machine is a nice way to think about it, which is true. I'm just going to talk for the next half hour so people are sitting in locations where they can see and listen better.
So you want us to be taking notes at you?
Yeah.
Wait, of functions? We're taking notes of this.
Take notes on functions.
No, it's like...
I think Abby said something too, it functions. It functions well. Which means that if I drop in x, it knows what to give me out for y. Okay, so a vending machine's a good example.
So that's the same as that?
Yeah. If I plug in a code on the vending machine, it knows what snack to give me, right?
You can have 2 X's.
If I just gave the vending machine $1, would it know which snack I wanted? No, because there's multiple things that are $1, and it wouldn't work. Okay.
You can have 2 X's but not 2 Y's. Right?
But you can have 2 Y's but not 2 X's. Could you have a vending machine that only had Doritos in it? And no matter what code you punch, you get out Doritos?
Yes.
Yeah, that would work. So your Y's can repeat, your X's can't repeat.
That's cool.
So for example, 2 can go to 7. But what if I drop in 2 and sometimes I get out 7 and sometimes I get out 5? Will the machine know what to do?
No.
No. So this would not work. But what if 2 goes to 7 and 3 goes to 7? Will the machine know what to do? Yeah. If I drop in 2, give me 7. If I drop in 3, give me 7. So you can't have this repeat to 2 different Y's, but you can have Y's repeat from 2 different X's. Okay? Oh, that's not a cross out. That's this. Okay? Anything else we remember about functions? We studied them for literally all of Algebra 2. What do we call the set of all possible inputs, or all the things we're allowed to drop in? The domain.
Yeah. There's something about range too, isn't it?
So the domain is all possible
solution.
And if this
inputs.
were like a graph, that'd be everything on the x plane, wouldn't it?
Yes, or x values.
Yeah.
And then the range is everything on the Y.
Range
Yes.
is everything, all possible outputs, and that would be on the y-axis. Don't look in front of the thing.
And actually, these words make sense in the English language because, what is your domain? Does anybody know what the word domain means, in the English language? Yes,
Domain
Shakir?
is your
Not in math. What is a domain?
I have no clue.
No, it's your kind of like your
like your
the
realm.
area.
Your realm, right? Your domain, kind of where you start from, right?
Where's your domain?
And then if you something flies away, it would be it would go on a range, right? You would
Yeah, range is like distance.
Right. Range is like distance or faring away. So this is where I start,
So
and this is where I'm going.
So a range within your realm.
Right. Or the range of your realm, right?
Exactly.
So domain is like my space. That's what I start from.
And how
And
far
range
it goes
is
within my
Range is how far it's going.
Yeah, I like that. Okay.
So sometimes our words in math are not that far off from our words in English.
Okay.
Okay. So domain is all the possible inputs. Range is all the possible outputs. Let's kind of do a quick example of one. Let's say f of x equals the square root of x minus 7. If f of x equals the square root of x minus 7, what happens when I drop in... No, that's a terrible example. 16.
Okay.
Oh, that's 9. That's 3.
I drop in 16. 16 minus 7 is
I knew you were going to use that 9.
9, and the square root of 9 is
The way.
3. So when I drop in 9, I get out 3.
Dress.
Everybody cool with that?
Yes.
Drop in 9, get out.
Dress.
What if I dropped in 2?
You drop in 2 with 2 minus 7, that's negative 5. The square root of negative... You can't find out what the square root of negative numbers are, can you?
So can I drop in 2?
No.
2 is not in the domain.
So you have to drop in.
Because you would get 2 minus 7, the square root of negative 5. And negative, you can't do the square root of negative 5.
So you can't plot that on the line.
So you have to drop in a number that is higher than 7. Can you drop in 7?
No.
Zero.
Yes.
Right. 7
So the domain is
7 0.
x is less than greater.
X has to be greater than or equal to
Wait, if
7.
you drop a 0, what's the 7? Which is 0.
Yeah, that's okay.
You can't find a square root of 0.
Yeah, you can. It's 0. Square root of 0 is 0.
So you only need to try one. You only need
Yo,
to try like
Why she
2
doing the thingamabobby?
Well-
examples to figure out.
Why she doing the thingamabob?
Just
Oh,
like
why
this
is she recording?
Right.
Because a lot of people aren't here because they're doing stuff, so she's recording for them because she's about to like teach for 45 minutes.
I'm going to talk for a while, and I don't want them to miss it.
Wow.
Okay.
You don't need to though.
All right. What's the... Then, if the smallest number I can drop in is 7, what's the smallest number I'm going to get out?
Like 0.
0. Am I ever going to get a number that's smaller than 0?
That's the beginning of the
Everything's just going to be bigger than 0. In calculus, actually, they have to find the domain and range without graphing, but you guys still, I would expect you to graph it and find the domain and range. Generally, you'll graph it to find the domain and range. All right. And you can always, it's often easier when you just look at a graph. Okay, so that's a review of functions. Today, we're going to talk about our trig ratios. We're going to define them 2 ways, and we're going to talk about how we can think about them as functions. All right, so how can we think about our trig ratios as functions? Everybody with me? Not really. Okay. So we're going to talk about our trig ratios. There are 2 definitions for the trig ratio. So this definition we're going to say is the right triangle definition.
So we just taking notes all day?
Yes.
It did not take me the whole time yesterday.
Shut up, Faith.
All right. Also, you're on video right now. Huh?
World star.
It's okay.
That's so drawing. You really should not be doing this, bro.
What if World star?
All right. Oh, goodness. So let's do our trig ratios. We start with what kind of triangle?
A special right triangle.
A right triangle. It doesn't have to be special. Start with a right triangle.
Oh, it's a basic right triangle, unfortunately.
Yeah, what was that?
He was in a meeting. It's fine. All right. What do we call this side right here?
There's a lead.
The adjacent, you mean? Okay.
You said that yourself.
That's the hypotenuse. The other one, the opposite.
But how do you
So how do you define the sine of theta?
Just saying that theta is, can I say it?
Yes, Manny.
It's opposite over hypotenuse.
Yes. This should be a review. How do we define the cosine of theta?
Well, what do you take? It's adjacent.
Of what? Theta?
Theta.
Theta, that's the circle thing.
Let's review theta for a second. We use theta, it's just a Greek letter, because we don't want to use x.
Oh.
And when we get to definition 2, you're going to see why we don't use x. X will be too confusing. Okay? So theta is just a variable. It's just the angle. Yeah, it represents the angle. Okay, so cosine is the adjacent over the hypotenuse. Tangent is the opposite of the adjacent. So let's think of this as a function machine.
Oh, this is the next class.
No.
Which one do you want to do, sine or cosine?
Sine.
Let's do the,
Let's do tangent.
Let's do sine because I did cosine yesterday.
Okay, well, we didn't have to cosine yesterday.
Yeah, but then if you talk to somebody in yesterday's class, you can see how they're the same or different.
Why would we have to
Yeah, we actually don't communicate with the other class.
I highly doubt that.
Because our even.
I really don't.
We
one
so
thing ahead of us.
All right, let's focus. Okay, so this guys. Shh.
I was thinking like the show.
How can people learn?
Man,
Oh, sorry.
if this is my function machine, what am I going to drop into the machine?
Something that's
Yeah,
like
an opposite.
And what's that number going to represent?
the
Theta, which represents what?
opposite of our hypotenuse, right?
No.
Not yet. What am I dropping in?
The angle.
The angle.
Oh.
So
I drop in an angle.
Okay.
I take the sine of that angle, and what do I get out?
The length.
Where's the length of that?
I get out this ratio.
Oh, that's
Opposite over hypotenuse.
so you solely get the ratio.
I get the ratio.
Gotcha.
If I dropped in 30 degrees, what would I get out?
I forget. You just did it.
The sine of 30 degrees.
for
1.5. That's solely.
big bird's world.
Guys. I don't have to drop in 30 degrees. What else could I drop in?
60.
60.
45.
45. Those are nice ones. What else could I drop in?
85.
85. 17.
32.
32. But this angle is part of a right triangle. Right?
Yes.
So let's talk about the domain. What is the smallest this angle could be?
45.
1.
45, right?
30.
Wait a minute,
It'd be smaller than 45.
30.
It'd be smaller than 30.
Is it 1?
0.
So I'd be saying 1. Who just said 0? If it was 0, would I actually have a triangle anymore?
No.
No. But is there a number between 0 and 1 that it could be?
Yes.
0.5.
0, 0,
And is there a number between 0 and 0.5?
I don't know.
Yes, there's infinite amount.
Yeah, there's definitely. It just has to be.
Infinite
Guys,
amount of them.
It has to be bigger than
0.
0.
Period.
That's it. Theta must be bigger than 0. This is the domain.
Why does theta have to be bigger than 0?
Because you can't
But
have a triangle.
that's for all of them.
If it's
right?
0, if they're flat like this, it's not a triangle anymore.
Oh, it must be bigger
So what
than
is this
this to
like?
keep the
This
right
like
triangle.
like point
Like,
zero
doesn't
zero
exist.
zero
That's
zero
fine.
zero zero 1.
That still would
That's
make a
still
triangle.
fine. I have a question.
Yes.
That what you just wrote down, that's fine for sine, co, and tan, right?
This would be the same for sine, cosine, and tangent.
That's just for
in
all
right triangle
trig
trig.
ratio
Yes.
functions, or just trig.
Yes. Okay, what's the largest theta could be?
You know what I'm saying? Whoa.
Well, whatever.
So now I'm going to make this as big as possible.
is 89.
60, right?
So why are you saying 89?
Because.
Oh,
yeah,
because if it's 90, then that means it's
It won't make a triangle anymore. Okay? Is there a number between 89 and 90 that it could probably be, though?
89.
Yeah.
Right. So it can be as close to 90 as possible, but it can't be 90.
It won't be a right
It
So
won't be a triangle anymore.
anything less than but not equal to 90.
Yes.
Órale, mira, I'm a genius. I like this.
I mean,
Wait, a right angle cannot be 90?
No. This angle can't be 90. Because if this angle is 90 and this angle is 90, you don't have a triangle anymore.
Theta.
You have square.
Well, you don't really have anything because we're assuming you don't have that third side, so you actually have nothing.
What's the range?
So what's the... Yes, Zach?
That's the domain of all the trig functions.
That is the domain, and please keep clarifying that because it won't be true about the range. But this is the domain of sine. It also is the domain of cosine and is the domain of tangent. They don't all have the same range.
Because the triangle could just not exist without that.
Right, because you won't have a triangle anymore if you don't have an acute angle. Because the sum of your angles has to be what?
180.
180. This one has to be 90. I only have 90 degrees left, right?
Yes.
So this one, if this can't be 0 because then I won't have, then this would be 90, right? So you have to have, you only have 90 degrees between these two,
okay,
right? You can't give them all to this one and have nothing there.
right.
And you can't have nothing here and give them all to that. It has to be somewhere in between.
So let's do this range.
So what's the range?
You know say.
So let's look at sine.
Orale, man, I see you.
Okay. It's a ratio. You think of it also as like a fraction.
Okay.
What is always the longest side of your right triangle? Hypotenuse. So this is always larger than this. Is anything ever going to be negative? No.
Because it wouldn't be a triangle.
Because it won't be a triangle anymore. So this number is always smaller than this number. So your fraction is always going to be less than what?
What? Or whatever.
1. Even if your hypotenuse is 2,000,
It's still.
your opposite can't be any bigger than
That.
2,000. It has to be like 1,999, which is still less than 1. Right? And if they were equal, they can't be equal because then you won't have a triangle anymore. You have 2 equal sides, you don't have any space for the third side.
So write that out in like that the other form.
So your opposite over hypotenuse, your sine of theta, and I'm just going to write it like this. Ooh, let me move it over a little bit. 0 less than sine theta. Less than 1. The ratio always has to be between 0 and 1. Because the opposite is always smaller than the hypotenuse.
Now, is that only for sine, though?
That's true for sine and cosine.
But not for tangent.
Tangent.
Because tangent, do you know which one's going to be bigger?
No idea.
No, because
No.
it's not.
Because they're different.
Because they're different. The range of tangent is actually negative infinity to positive infinity. It could be anything.
Wow, I want to write that down.
That's kind of annoying.
Oh, so that's all for range.
Wait, so that's the range.
This is the range of sine.
Whatever.
It's also the range of cosine, because same thing, adjacent has to be shorter than hypotenuse. But the range of tangent is all real numbers, because you never know which one's going to be bigger.
Okay.
So can we write the range of tangent?
You can write the range of tangent. We're going to review it again. Do you think my screen just went out? Do you think that means it stopped recording? No. Okay.
So it's negative infinity to infinity.
Yes, the range of tangent.
Is it less than or less than and equal to? Or
You can't equal infinity.
so just range
So it would be negative infinity is less than tan theta
less than.
is less than infinity. And it would also be 0 is less than cosine theta is less than 1. And I wrote, do you see I wrote tangent there and sine there instead of y, so you wouldn't be confused as to which was which. Okay, so that's right triangle trigonometry. And if we stuck with the right triangle, we wouldn't be able to do that many angles. We'd only have angles that are between 0 and 90. But what do we know? What kind of other angles could we have?
I don't know anything.
2 angles.
We can have angles that are bigger than 90.
Muy grande.
Can we have angles that are bigger than 360?
Mucho.
Think about all the angles that are on our unit circle,
Mm-hmm.
right? And can I go past 2 pi?
Yes.
Yeah. So I really could go forever in either direction. So it'd be really nice if I could do more than just between 0 and 90.
Mm-hmm.
So we're going to redefine the trig ratio.
So why did
Whoa,
we write
hold
it?
on. So you give us.
I told you there were 2 definitions. This is the first definition.
Oh, I thought you meant like 1 and 2.
I'm going to give you a new definition.
That's so not cool.
Down with
I'm
the
excited.
trig
That's too much thinking.
New definition.
Thinking makes
Establish a new order.
Are you ready for the new definition?
The new world order.
And I want to change the domain, right? Trying to change the domain.
So you're changing the rules of the domain.
No, the whole point of finding a new definition is because my domain is too small. I want to expand my domain. I want to be able to find the sine of 270.
For anyone watching this, you don't have to tell it a way to erase it. You can just press pause. Because I bet you somebody's like, wait, no, stop. And they're like, oh, right. There's always that one. There's always that one.
There is. You erased too fast. All right, are you ready for the new definition?
Sure.
Okay, so this is going to be the unit circle definition.
You didn't, oh, the range stays the same?
We'll see. We don't. Let's
We
put
didn't-
a question
We
mark
didn't
there.
erase it.
We know we want the domain to change. Let's
see.
see what happens to the range.
I understand.
Unit circle definition. Okay, this is the unit circle definition.
So we don't rewrite that?
So we're going to redefine them, remember?
Oh,
Okay. So we're going to start by drawing a...
Hey, yo, who just yawned? That's not funny. You better stop. Yeah,
You can do that. We're going to start by drawing a unit circle.
I'm only talking because I want people to have something to listen to.
Make you feel like it's actual class.
Yeah, exactly. I just want to bring it up.
Let's take a point on the unit circle. I'm going to call this point P.
Why not K?
Because the word point
Because the word point starts with the letter P.
Oh.
Wow.
I put point in the middle.
I'm gonna say the x value of this point is x, and the y value of this point is y. Earth shattering, I know.
That doesn't make any sense. How are we supposed to figure it out?
All right, so here's my
We're watching Dora.
angle right here, theta. And I want to find the sine, cosine, and tangent of theta.
I'm getting so.
So let's imagine there was a right triangle there. Here's my right triangle.
Okay. You over there. I see. Okay.
That's not my right triangle. Actually, not my triangle.
What you say this hour?
I'm putting a right triangle there because we're going to take the right triangle definition and apply it to the unit circle.
Okay.
So on my right triangle,
Erase like that.
how long's the base of my right triangle there?
It's 1. No, wait. Oh, sorry. I was thinking about the
It's
hypotenuse.
like, isn't it x over some?
So the distance from here to here is just
X.
x. And the distance from here to here is just
He's shook.
y.
Oh.
You okay?
He's bugging about a buzz.
Oh. No, I hate that too. Ever been okay with x and y being the lengths of the triangles? Okay. What's the hypotenuse of the triangle?
Okay. I'm sorry. What? It's 1.
How do you know the hypotenuse is 1?
Because it's no
It's
because
a unit circle, and this is the radius of the unit circle. So it must just be
Yeah, man.
1.
Why is it one?
Because
Because
it's the
it's a
radius.
unit circle. Yeah.
Oh, it came over there now. Because it's a radius of the circle.
That was a fly, by the way. You guys think that's a
Do
mistake?
you see how this hypotenuse is the radius? It's the same as this here. Same as this here.
So all the radiuses of a hypotenuse is 1?
Guys, all the radiuses of a unit circle are 1.
Small little.
Okay. The radius doesn't change on the circle no matter where you go. Remember from geometry? Sort of thing.
Sort of kind
All right, you ready for new
Usually in
definitions?
geometry,
Yes.
like the radius is 3, and find the diameter.
But no matter where I drew the radius, it was still.
So we're just deciding it's 1.
Well, the unit circle.
The ratio is
Specifically for this unit circle, it's 1.
Let me say, what if I told you this to start, right?
Oh yeah, because all those points is 1. Okay.
So you know from here to here is 1, so from here to here must also be 1.
no matter what.
If it was on the other side, would it be negative 1?
The radius would still be 1 because the radius is the distance.
You can't
All right.
say negative this.
So, now let's redefine sine, cosine, and tangent.
Use the same.
So look at theta. Sine is opposite over hypotenuse. What is opposite theta?
Why?
Y.
Oh, that's how you want to
And what's your hypotenuse?
It's 1.
1. So y over 1 is just
What?
y.
What are you smoking? Okay. And then cosine
Is
is just x.
Let's do that again. How did I get y?
Okay, y over 1 is just 1.
Opposite is
What?
y. And the hypotenuse is, and y over 1 is just y.
Mire, es el mismo con
Cosine is adjacent over hypotenuse. What's adjacent?
X.
X over 1 is just
X.
x. This is another reason why we work on the unit circle, so I don't have to worry about a denominator.
yeah.
So sine of theta is y, cosine of theta is x. Tangent? I'm waiting for a few more people to write it down.
Oh, you mean tan? Are we doing tan?
Tan.
Isn't there y over x?
Tangent is,
It's already written.
yes, Caitlin?
Y over X.
Yes.
You could just put a line between the two. From sine to cosine.
Oh, sine over cosine.
We're not gonna do it.
We'll get there.
Miriam.
So now when I drop in, everybody with me? Everybody cool? Okay, so now if I want to find the sine of theta, I drop in an angle,
Which is your y.
and then I just take its y value on the coordinate. So I don't get a ratio anymore. I just get the y value on the coordinate
For
for anything.
oh.
Wait. Okay. All right. And
What?
then if this
Where
were,
do you go?
and then if this were cosine, then you just drop the angle, get out x, right?
Yes.
Okay. Like,
So, if you want, it probably would be helpful to look at your unit circle right now.
it's okay. I'm good.
So let's look at our unit circle. Let's drop in pi over 6.
She gave us an option and then took it away.
Pi over 6 is the same as 30 degrees, right?
Uh-huh.
Yeah.
All right, what is the y coordinate when you're at pi over 6, which is 30 degrees? Look at your unit circle.
Wait, how come you? I'm taking notes, but I didn't get that. How come you changed the opposite?
Because now I'm not saying sine is the opposite over the hypotenuse. I'm saying sine is the y.
Oh wow.
So you know that's that one.
Yes. So you go to pi over 6 on your circle, and you look at the y value.
Bet.
So go, got to get your circle.
Go
Go to pi over 6
I get good. So
and look at the y value.
tell you right here. Let me tell him for her.
And I don't necessarily want people to tell me because I just want everyone to look on
Oh,
their own.
okay. All right.
But I've shown.
Did you find it, Haja?
Go to pi over 6.
Go to pi over 6.
Pi over 6.
And what's the y value?
half.
And now we thought pi over 6 is the same as 30,
It's 1/2.
right? Pi over 6 is the same as
Oh yeah, 30 degrees.
30 degrees. So didn't we get the same answer even though we used the other definition?
Yeah. Okay.
Yeah.
I see. All right. That was pretty good.
Pretty cool.
Yeah, pretty cool.
And then 30 you didn't have to put in it.
But now,
Pi over 6 you didn't have to.
right, before, when I only had a right triangle, I couldn't put in 2 pi over 3, right?
Yeah.
Which is 120. Now I can. What's the y value of 2 pi over 3?
Square root of 3 over 2.
Square root of 3 over 2.
Wait, can you repeat that?
So before, let me change colors.
Okay, you need to take
Before,
your
I
angle.
couldn't plug in
Well,
2
set
pi
it
over
up.
3.
No, we don't want that negativity.
Because that's 120 degrees. It was too big, right?
Yeah, I saw it.
When I was only had the right triangles. Can you draw a right triangle with 120 degrees?
No.
No. Okay? But now that we're talking about the unit circle, go to 2 pi over 3. What's the y value?
It is negative 1 pi.
2 pi over 3 is in which quadrant? The y value.
Square root of 3 over 2.
Thank you. So now, what did I just do to my domain?
Oh my god, it's fun.
I expanded my domain by a lot. Because how many angles are on the unit circle?
You see, yeah.
Infinitely many angles are on the unit circle. Can I go backwards forever on the circle?
If you want to.
Yeah, and then I could go forwards forever on the circle?
Sure.
Yes, so now my domain for my angle for all 3 trig functions is negative infinity.
Perfect. That's exactly what I want to write down.
Is that the ultimate goal? To do anything possible?
The ultimate goal would be for everything to be possible, yes. So on the unit circle, I have a way bigger domain than I do with the right triangles.
It's like forever.
It's like forever thing. There's now no angle that's out of
So if
bounds.
somebody says, what's the domain of the unit circle? You say
Well, no, what's the domain of sine
Oh.
on the unit circle? It's negative infinity to infinity. It actually is the same for cosine and tangent, though.
So it is just relevant.
Because this is just the angle. So the angle can always be, the angles are always the same, no matter which function I use.
Well, what's the range?
What's the range?
Found you go.
So range is the y values.
Yeah.
What's the smallest y value on the unit circle?
What?
Is it 1
Oh,
over
wait.
square root 2?
Well, it can't be 0 because then it's not
It's not
an
a half,
angle.
is it?
What's the smallest one on the
Negative a half?
Negative 1.
negative 1?
Oh, wow.
What's the highest value on the unit circle?
Uno.
1.
So it's negative 1.
So did the range change?
Yes.
Yeah.
Yeah.
It goes from negative 1 to 1 now instead of. So now you can have ratios that are negative.
The range of sine or the range of the unit circle?
The range of sine. You're not taking the unit circle is just a thing that's not changing. So you're not. So the range of sine.
Is that sine and cosine or just
Yes,
sine?
this is also the range of cosine.
Tan is gonna be like
Negative and positive.
okay.
Yeah, this is.
I was about to say something and then I got. Oh, do you see why I'm not using x and y here? Right, because x and y are here and here. It'd be very confusing if I also used x and y here.
Yeah, I would have equal ones.
So that's why I stopped using x and y. How about this? How about this? I'm going to be finished in like 3 minutes. Jakir, you need to be in class.
I know, but I need to.
Ren, you're now wasting 3 minutes that I would have been finished. My answer is no. Any questions? So to summarize, we learned how many ways to define sine, cosine, and tangent today? 2. 1, what was the first way? Right triangles. What was the second way?
Unit
Circle. Which gives us more angles?
Oh my
The unit circle. Gives us way more angles.
What do you mean it gives us more angles?
If I was on the right triangle, I could only use acute angles. Now that I'm on the unit circle, I can use any angle I want. Now there's infinitely many angles. I mean, there's still infinitely many angles, but now I can go below
So
0.
for the right triangle one, you can't plug in 100.